Life on Earth has a history. It is a long history. It is a violent history. We walk around on a planet that seems stable. The ground feels solid, the sun comes up, the seasons change, but this stability is an illusion, a brief moment of calm in a story filled with chaos. The real story of our world is written in the rocks beneath our feet, and that story tells us that life can be wiped out on a massive scale. These events are called mass extinctions. They are not just about a few species dying off. They are about the entire global ecosystem collapsing. They are moments when the rulebook of life is torn up and rewritten. Scientists generally agree on five huge ones, the big five. Each one was a planetary catastrophe. Each one was caused by something different, and each one serves as a warning. Understanding them is not just about understanding the past. It's about understanding our present. The first major crisis happened around 445 million years ago. This was the Ordovician-Silurian extinction. At the time, life was almost entirely in the oceans. The seas were full of weird and wonderful creatures. Trilobites, which looked like armored woodlice, scuttled along the seabed. Brachiopods, shelled animals that looked a bit like clams, filtered food from the water. A vast coral, like reefs, were built by strange organisms. It was a thriving, complex world. Then, it fell apart. Over the course of a few million years, about 85% of all marine species vanished. It happened in two pulses. The first punch was an ice age. A huge supercontinent called Gondwana drifted over the South Pole. As it settled there, massive ice sheets began to form. This had a dramatic effect. All that water being locked up in ice caused sea levels to plummet. The shallow, sunlit seas where most life existed simply drained away. It was as if someone pulled the plug on the bathtub. Habitats were destroyed on a global scale. Life that was adapted to warm, tropical waters had nowhere to go. It froze or was stranded. Then came the second punch. The Ice Age ended. It may have ended as quickly as it began. The glaciers melted, and all that fresh water poured back into the oceans. Sea levels rose rapidly, flooding the newly exposed continental shelves. But the water was different now, the chemistry was all wrong, the rapid melting likely messed up ocean circulation patterns. This could have disrupted the flow of oxygen and nutrients. The survivors of the first pulse now faced a new world of unstable, oxygen-poor waters. They couldn't adapt. The combination of rapid cooling and habitat loss, followed by rapid warming and ocean chaos, was too much. The planet's life support systems flickered, and the first great chapter of complex life came to a grim end. The cause wasn't a monster from the sky. It was climate change driven by geology and geography. The life, however, is resilient. The survivors spread out and evolved. The world recovered. Fish developed jaws and became fearsome predators. On land, the first simple plants began to colonize the barren rock. For millions of years, life rebounded and diversified, but the planet wasn't done yet. The second mass extinction came about 375 million years ago, during the Late Devonian period. This one was different. It wasn't a single sharp event. It was a long, drawn-out agony that lasted for maybe 20 million years. It was a series of extinction pulses. Again, the victims were mostly in the sea. The magnificent coral reef systems of the Devonian, the largest the world had ever seen, were wiped out. They wouldn't recover for over 100 million years. The fish took a massive hit. This period is often called the Age of Fishes, but by the end of it, many of the most dominant groups, like the giant armored placoderms, were gone forever. What caused this long decline? The main suspect is a surprising one: plants. During the Devonian, plants on land had a major breakthrough. They evolved deep roots and grew into the first real forests. This changed the world. For the first time, deep, rich soil was being created. These new deep roots broke up rocks, releasing huge amounts of nutrients. Rain and rivers washed these nutrients into the oceans. This sounds like a good thing, but it was a curse. The flood of nutrients caused massive algal blooms, a process we now call eutrophication. Trillions of tiny algae would choke the surface waters. When they died, they sank to the bottom. Bacteria then got to work decomposing them, but this decomposition process uses up oxygen. With so much dead algae to break down, the bacteria sucked nearly all the oxygen out of the bottom waters. The oceans began to suffocate from the bottom up. These anoxic events spread across the globe, creating vast dead zones where almost nothing could survive. The creatures of the seafloor, unable to escape, simply died. So the very thing that made land habitable, the rise of forests, may have poisoned the oceans. It shows how interconnected everything is. A change in one part of the system can have devastating, unexpected consequences elsewhere. There may have been other factors. Some evidence points to large volcanic eruptions that could have contributed to climate change. But the story of the Late Devonian is a powerful lesson in how a biological innovation can destabilize the entire planet. After the Devonian crisis, life once again recovered. Amphibians roamed the swampy forests. Reptiles appeared. The continents were slowly crunching together to form the supercontinent of Pangaea. But all of this was building toward the greatest catastrophe in the history of life. It is known as the Permian-Triassic extinction. It happened about 252 million years ago. It is nicknamed the Great Dying, and it earned it. This was the closest life on Earth has ever come to being completely extinguished. The numbers are hard to comprehend. Around 96% of all marine species disappeared. About 70% of all land vertebrate species vanished. Insects suffered their only mass extinction in their entire history. Trees, plants, plankton, everything was hit. It was a systematic, brutal demolition of the global ecosystem. For a long time, scientists had no idea what could have caused such a complete collapse. An asteroid impact was a possibility, but the evidence wasn't there. The real culprit turned out to be something from within the Earth itself. The cause of the Great Dying was volcanoes, but not the kind of volcanoes we think of today. This was an event on a scale that is almost unimaginable. In a region of modern-day Siberia, the ground split open. Fissures miles long tore through the crust, and lava poured out. Not for a week, or a year, but for perhaps 1,000,000 years. This event created a vast region of volcanic rock called the Siberian Traps. It covers an area larger than Western Europe. The amount of lava was enough to bury the entire planet several feet deep, but it wasn't the lava that killed the world. It was the gases. The volcanoes pumped colossal amounts of carbon dioxide into the atmosphere. This triggered a runaway greenhouse effect. Global temperatures soared, perhaps by as much as 10 degrees Celsius. The heat was just the beginning of the horror. The oceans warmed up along with the atmosphere. Warm water holds less dissolved oxygen than cold water, so the oceans began to lose their breath. The anoxic dead zones from the Devonian extinction came back, but this time they were bigger and more persistent. A deadly feedback loop began. As life in the oceans died and rotted, more oxygen was consumed, creating more dead zones. Some scientists think that in these stagnant, oxygen-free waters, bacteria that produce toxic hydrogen sulfide gas thrived. This poison could have bubbled up out of the water and into the air, killing life on land. The oceans also became acidic as they absorbed CO2 from the air, making it hard for creatures with shells or skeletons to survive. On land, the situation was just as dire. The intense global warming would have created unbearable heat, especially in the interior of the supercontinent Pangaea. The volcanic eruptions also released sulfur dioxide, which would have created intense acid rain, stripping nutrients from the soil and poisoning lakes and rivers. To make matters even worse, the Siberian lava flows burned through huge underground coal and gas deposits, releasing even more greenhouse gases. It was the perfect storm. The planet's systems were pushed past their breaking point. The web of life wasn't just damaged, it was burned, suffocated, and poisoned to the brink of total annihilation. The Great Dying shows the ultimate power of geology to dictate biology. It was a glimpse of what happens when the planet's thermostat breaks completely. The world that emerged from the ashes was a strange and empty place. It took millions of years for life to truly recover. The survivors found a world of opportunity. On land, the path was cleared for a new group of reptiles to take over. These were the dinosaurs. The fourth mass extinction, the Triassic-Jurassic extinction, happened about 201 million years ago. It was this event that truly cemented the dinosaurs' reign. Before this extinction, the world was full of a variety of large reptiles and amphibians. Giant crocodile-like phytosaurs hunted in the rivers. Large, bulky reptiles called adosaurs were the dominant herbivores. The dinosaurs were around, but they were mostly small and not yet in charge. This extinction changed all that. It wiped out most of their competitors. The cause sounds familiar. It was another massive volcanic event. As the supercontinent of Pangaea began to tear apart, the Atlantic Ocean started to form. This breakup was accompanied by colossal volcanic eruptions. This region is now called the Central Atlantic Magmatic Province, or CAMP. Fissures opened up from modern-day Brazil to Spain, gushing lava. Once again, it wasn't the lava itself, but the gases that did the damage. Huge quantities of CO2 were released into the atmosphere. The planet warmed rapidly. The oceans became more acidic. It was a repeat of the Permian extinction, though not quite on the same apocalyptic scale. But it was enough. Many of the large amphibians and non-dinosaur reptiles couldn't cope with the rapid climate change and the collapse of their food chains. The dinosaurs, for reasons we don't fully understand, were better able to survive. Perhaps their metabolism or breathing systems gave them an edge in a hot, low-oxygen world. Whatever the reason, when the dust settled, the dinosaurs found themselves in a world with far less competition. They took over, diversifying into the giants that would dominate the planet for the next 135 million years. This extinction shows that it's not always the strongest that survive, sometimes it's the luckiest. The dinosaurs were in the right place at the right time to inherit the Earth, and that brings us to the most famous extinction of all. The fifth one, the Cretaceous-Paleogene extinction, which happened 66 million years ago. This is the one that killed the dinosaurs. For over 150 million years, they had been the undisputed rulers of the land. Giant marine reptiles like mosasaurs ruled the seas. Pterosaurs soared through the skies. The world was theirs, and then, in a geological blink of an eye, they were gone. For decades, the cause was a mystery. Then, in the 1980s, a team of scientists found a thin layer of clay in the geological record all around the world. This layer dated precisely to the time of the extinction, and it contained a shocking amount of iridium, an element that is rare on Earth's surface but common in asteroids. They proposed a radical idea: the dinosaurs were killed by the impact of a giant asteroid. It was a controversial theory, but the evidence mounted. A decade later, the smoking gun was found a massive impact crater over 100 miles wide, buried beneath the Yucatan Peninsula in Mexico. It was named the Chicxulub crater. The story became clear. An asteroid, estimated to be about 6 miles wide, slammed into the Earth. The energy release was more than 1 billion times that of an atomic bomb. The immediate effects were apocalyptic. The impact would have triggered gargantuan earthquakes and tsunamis that washed hundreds of miles inland. It blasted a hole in the atmosphere, ejecting molten rock and debris back into space. As this material fell back to Earth, it heated the air to oven-like temperatures, sparking global firestorms. Anything not in a burrow or underwater would have been cooked, but the worst was yet to come. The immense amount of dust, soot from the fires, and sulfur from vaporized rock was thrown high into the atmosphere. This cloud spread around the globe, blocking out the sun. The world was plunged into a dark, cold impact winter that may have lasted for years. Photosynthesis stopped. Plants died. The herbivores that ate the plants starved. The carnivores that ate the herbivores then starved. The entire food chain collapsed from the bottom up. It didn't matter how big or strong you were. You couldn't fight a world without sun. In the oceans, the story was similar. The loss of sunlight killed the plankton, the base of the marine food web. The impact also likely caused intense acid rain, which would have acidified the surface of the oceans. About 75% of all species on Earth were wiped out. The giant dinosaurs were gone. The marine reptiles were gone, but some creatures survived. Small, burrowing mammals. Some birds, which are the direct descendants of dinosaurs, turtles, crocodiles, fish. They were able to hide or to find food in the rotting detritus of the dead world. When the sun finally returned, they emerged into a world free of giant predators. This was the moment that gave mammals their chance. Without the asteroid, we almost certainly would not be here. The end of the dinosaurs' reign was the beginning of our own. It's also important to note that, just like in other extinctions, there may have been more than one killer. Around the same time as the impact, another massive volcanic event was underway in India, creating the Deccan Traps. Some scientists argue that these eruptions had already started to poison the atmosphere and weaken ecosystems. The world may have already been sick. The asteroid was the final, brutal blow. That is the story of the Big Five. A story of ice, of plants, of volcanoes, and of an impact from space. They show that life is fragile. They show that the Earth's systems can be pushed to a breaking point. And they lead us to a difficult and uncomfortable question. Are we in the middle of the sixth mass extinction? The evidence is mounting, and it is disturbing. Scientists who study extinction rates have a concept called the background rate. This is the normal, slow rate at which species disappear over geological time. The current rate of extinction is estimated to be 101,000 times higher than the background rate. And it's accelerating. Species are vanishing faster than they have at any point since the dinosaurs died out. We are losing amphibians, mammals, birds, insects, and plants at an unprecedented rate. If this is a mass extinction, what is the cause? There is no giant volcano erupting in Siberia. There is no asteroid hurtling towards us. The cause is us. We are the cataclysm. We are doing it in several ways, and they echo the causes of the ancient extinctions. We are destroying habitats, we cut down forests for farms and cities, we drain wetlands. We dam rivers. This is like the sea level fall in the Ordovician, wiping out habitats on a global scale. If a species has nowhere to live, it will go extinct. We are changing the climate. By burning fossil fuels, we are pumping enormous amounts of carbon dioxide into the atmosphere, just like the volcanoes of the Permian and Triassic. The planet is warming at a speed that most species cannot adapt to. This is disrupting weather patterns, causing more extreme droughts, floods, and heat waves. Our oceans are absorbing much of this CO2, causing them to become more acidic. This threatens coral reefs and any creature with a shell. We are running the same deadly experiment as the Siberian and Camp volcanoes. We are polluting the planet. Plastics choke our oceans. Chemicals from farming run into our rivers, creating the same kind of oxygen-starved dead zones that characterize the Devonian extinction. We are overhunting and overfishing, driving species like sharks, tuna, and rhinos to the brink. We are also moving species around the globe, introducing invasive predators and competitors to ecosystems that have no defense against them. We are a force of nature unlike any other. We are a single species, but we have the impact of a geological event. Our global civilization is acting like a slow-motion asteroid impact. We are the first species in the 4.5 billion year history of this planet to understand the concept of mass extinction. We are also the first species to knowingly cause one. That is the profound and sobering reality. The story of Earth's mass extinctions is not just ancient history. It's a mirror. In the past, the triggers were random and blind. A continent drifts to the wrong place. A new type of life evolves and accidentally destabilizes the world. A plume of hot rock from the mantle breaks through the crust. A rock falls from the sky. These were events without intent. This time, it's different. The cause is a species that can make choices. A species that can see what is happening. We can read the story in the rocks. We understand the carbon cycle. We know what happens when you block out the sun or poison the seas. The rocks tell us that the world systems are complex and can collapse with shocking speed when pushed too far. They tell us that life is resilient in the long run, but that the long run doesn't include most of the species that were around before the collapse. Recovery takes millions of years, and the world that comes after is always profoundly different. The history of mass extinctions is a story of thresholds and tipping points. Life is tough, but there's a limit. The planet has a budget, and we are spending it too fast. The past doesn't tell us what to do. It just shows us the consequences. It lays out the stakes. The future of countless species and the stability of the only world we have depends on the choices we make now. We are writing the next chapter in the history of life on Earth. The question is whether it will be another story of extinction or the first story of a species that saw the cliff edge and chose to turn back.